This is a mini lecture on graphing position. First, some vocabulary. What do we mean when we're talking about position? Position is the length of an object from an origin. We can see an origin here represented by the house. On the number line, the origin is represented as 0. So once again, your position is the length that an object is from an origin. It is measured in meters. We can always assume that position is measured in meters. What does that mean? It means position is a distance or a length. Position can be a positive or negative number, indicating direction. So position is a length and a direction. The vocabulary word for this is called a vector. It has length and direction. Let's look at two examples. Person 1 has a position of -4 meters. Let's look where she is from the house. Remember, we need distance and direction. The house is at the origin, or 0, so this means that person 1 is 4 meters to the left of the house. We indicate that with -4 meters. Let's look at another example. Person 2 has a position of 5 meters. That's +5. So person 2 is 5 meters away from the origin in the right direction. Notice how person 1 and person 2 are in different positions relative to the house or the origin. A new vocabulary word is called velocity. Velocity is speed in a given direction. You might see the word velocity quite a bit in this unit. It considers how fast an object is traveling and in which direction it is traveling. How fast is speed, but when you give it a direction, you get velocity. How fast and in which direction. The units for velocity are meters per second. Let's look more at velocity with some examples. Here's person 2 again. This time person 2 is starting with a position of +4. But look at the example. Person 2 is traveling away from home in the positive direction. So this person is moving away from the house, away from the origin. That's a positive velocity. Let's look at a negative velocity. Person 2 is traveling toward home. Negative velocity. Traveling, moving back to the origin. What would this person's motion look like if velocity was 0? This person would be not moving at all. Now let's look at a position versus time graph. A position versus time graph shows the position of an object at a given time. It can also show change in position as time passes. We put time on the horizontal or x-axis and position on the y-axis. Let's look at some position versus time graphs. This one has a positive slope. There's two things we can gather from this graph. The first is that the object starts at the origin. Look at where position is at 0, all the way at the bottom of the y-axis. At time 0, position is at 0, starting at the origin. As time advances, as we move further in time or as time passes, position grows in the positive direction. It gets larger. If position is growing over time, you are traveling away from the origin in a positive direction. Let's look at another one. This time we have a negative slope. This object is starting away from the origin. At time 0, position is not 0. Position is higher than 0. But as time increases, as time passes, position decreases. That distance from the origin gets smaller. It's traveling toward the origin. Remember when we said no slope? Position versus time. This line is flat. It is parallel with time. What does that mean? It means that as time advances, the position doesn't change. That means this object is not moving at all. Because it starts at time 0, it starts higher than position 0, it starts away from the origin, and it doesn't move. It stays put over time. Question: which object is moving faster? Is it the red object or the blue object? If you want to know which one's faster, you need to look at the slope of the line. The blue line has a steeper slope. So as time progresses, as time passes, the blue object will change position faster than the red line. Let's pick out a time. Let's look at this time right here and just take it straight up. At this time, let's say this is 10 seconds right here. At this time, the red object is about at this position. But the blue, the blue object is much higher. The blue arrow shows an object moving faster. The slope of a position versus time graph is its velocity. Let's practice. Describe the motion of an object represented by this graph. Let's look at our axes, position and time. What is happening to the object at each letter? Well, before we even get to A, where is the object starting? At time 0, position is 0. The object is starting at the origin. And what's our object in this graph? Look at the title. It's a cow. So our cow is starting at the origin. We can call the origin the farm. The cow is at the farm at time 0. And then the clock starts ticking. The cow moves away from the origin. How far did it move? 2 meters. How long did it take to get there? About 1.5 seconds. Then what does the cow do? Once it reaches 2 meters, after 1.5 seconds, it stays put. It stays put. Does not move from 1.5 seconds all the way to 4 seconds. Then what does the cow do? From 4 seconds to it looks about 6 seconds, the cow starts moving again. Does it go back to the farm? Does it go back to the origin? Or does it keep moving away from it? Well, this is a positive slope. Just like this one, a positive slope. So it continues moving away from the origin. Then at the 6-second mark, at about 6 seconds, what does the cow do again? Well, it looks like, because this line is flat, it looks like the cow stops. Starts at the origin, moves forward, then stops. Moves forward again, then stops. Let's look at question 3. When is the object moving the fastest, and how do you know? Well, it's not at B, and it's not at D, because we know it's not moving at all at these locations, or at these points in the graph. That leaves A and C. You could calculate the slope. Let's see, over 2 seconds, it moves a total of 3 meters. Or I'm sorry, of 4 meters. My goodness, 1, 2, 3, 4 meters. And here it took 1.5 seconds to go 2 meters. So you could calculate and find out that C is a faster slope, or you could just look at the slope of the line and notice that C has a greater slope. It's steeper. One more thing. We will talk about this later and have more often conversations about this, but do not say that the cow is jumping in the air and getting higher. The cow is not going up for a slam dunk. The cow is on a flat line, moving either away or toward the origin, just like these people. They're not going up and down. They're going either away or toward the origin. Make sure you frame your motion in this way, on a horizontal plane. Want more practice or more resources? They will be linked to this last slide.